Question number 18. AB is a uniform rod of length 60 centimeters and weight W kilogram weight. The weight of the rod AB is unknown. Here is the weight AB. The end A is attached to a hinge fixed on a vertical wall, and the end B is tied by a string of length 80 centimeters. So the end B here is attached to a string. The length of the string BC equals 80 centimeters. Its other end is fixed to a point on the wall vertically above A directly. The other end of the string C here. The point C vertically directly above A, such that AC equals 100 centimeters and at distance 100 centimeters of it. Then the rod became in equilibrium. So find the tension in the string, here the tension in the string, and the reaction of the hinge R. So we can choose the triangle ADC, this triangle ADC, as the triangle of forces because the three forces parallel to its three sides. The force W, the line of action of W here, is parallel to AC, and the line of action of R coincident with the side AD. Also the line of action of the tangent here D is coincident with DC, and the three forces are in the same cyclic order. So we can choose this triangle as the triangle of forces. Before that, you have to know that the three forces, the weight W and the tangent and the reaction, must intersect at one point according to the theorem as the rod in equilibrium. So to apply triangle of forces rule, we must know the side length of this triangle. We know that AC equals 100 centimeters, so we have to calculate the length of AD and the length of DC. Okay, now we know that AB is a uniform rod, so its weight acts on its midpoint here, the point E, and now we have ED is parallel to AC, and E is the midpoint of AB, so D also is the midpoint of AB. So we can deduce that CD equals 80 divided 2, which equals 40. So CD equals 40 centimeters. And we have AC equals 100 centimeters. So the required now to calculate the length of the side AD, and I will use similarity, okay, as DE is parallel to CA. So we have two similar triangles, DBE and CBA, this triangle. The triangle DBE similar to triangle CBA. Okay. Now to find DA, the length of DA, first we must prove that the angle B equals 90 degrees. Starting from here, in triangle ABC, here in triangle ABC, we have AC equals 100 centimeters and the AB equals 60 and the BC equals 80. So AC power 2 equals 100 power 2, which equals 10 thousandths. AB square plus CB square equals 60 square plus 8 square, which equal also 10,000. So AC square equals AB square plus CB square, and we can consider that AC is the hypotenuse in this triangle ABC. So measure of angle B equals 90 degrees. I'll use it later to find the measure of the inclination angle between the reaction and the AB. I will use it later, measure of angle B, to find the included angle between AD and AB. But now I'll use similarity to calculate the length of AD. Since DE is parallel to CA, then triangle EBD, triangle EBD, this triangle is similar to triangle ABC. Note that I wrote these two triangles in the same order of the vertices, as angle E equals angle A in measure, because ED is parallel to AC, and so on. Now we can write this proportion: EB over AC equals BD over BC equals ED over AC, like this. And now I'll substitute using the given. We have EB equals 30, as E is the midpoint of AB and AB equals 60 degrees. So EB equals 30 centimeters. Sorry, AB equals 60 centimeters. Equals BD, it is unknown. I wrote it over 80. 80 is the length of BC, equals ED over 100. 100 is the length of AC. And from that, I can calculate the length of BD and ED. And I'll substitute. I calculate these two sides as BD here. BD equals 80 multiplied 30 over 60, which equal 40. Divide 30 equals 1, divide 30 equals 2. 80 divided 2 equals 40. Also 30 divided 30 equals 1. 60 divided 30 equals 2. And 100 divided 2 equals 50. So now we know that BD equals 40, and ED, where is ED? ED equals 50. ED equals 50. Now I have to calculate the length of AD. It is the last side in triangle ADC. AD equals square root of 60 square plus 40 square. AD equals square root of 60 square plus 40 square. You know that D is the midpoint of CB. So the length of DB is 40 centimeters also. Right? So AD equals 20 root 13. Now we can say that triangle ADC is the triangle of forces. So R over the length of AD equals T over the length of DC equals W over the length of AC. And we can substitute AD equals 20 root 13, and DC equals 40, AC equals 100. So R here, using cross multiplication, R equals 20 root 13 multiply W over 100. 20 root 13 over 100 multiply W. So the result equals root 13 over 5. W, the result or the magnitude of the reaction it will be in terms of W, the weight of the rod. To simplify this, divide 20 equals 1, divide 20 equals 5. So 1 multiply 13 over 5 equals root 13 over 5 W. And also I'll calculate T, the tangent in the string, cross multiplication, 40 multiply W over 100. 40 multiply W over 100, divide 20 equals 2, and divide 20 equals 5. So the result equals 2 over 5 W kilogram weight. Now we want to calculate the measure of the angle theta. This angle included between AD and AB. So tan theta equals dB over AD, opposite over adjacent. What is the length of dB? It's 40. What is the length of AB? Equals 60. So tan theta equals dB over AB, which equal 40 over 60, which equal 2 over 3. And then theta equals tan minus 1, 2 over 3, which equal 33 degrees and 14 minutes. Next question. Here we have AB is a uniform rod of length 90 centimeters and W weight kilogram. So the length of AB equals 90 centimeters. I will write it here. AB equals 90 centimeters. And its weight equals W. Its end A is fixed to a vertical wall. Here is the point A by a hinge, and the rod is kept equilibrium horizontally. So we draw AB in a horizontal position. Here is the rod AB. In a horizontal position by means of a string of length 50 centimeters. Here is the string here of length 50 centimeters. 50 centimeters. Okay, one of its ends is tied at a point C. This point C on the rod. Here is point C on the rod. Here. At distance 30 centimeters from A. So AC, the length of AC equals 30 centimeters. The other end of the string is fixed at a point D. Here is the point D. On the vertical wall above A directly. Calculate the tension in the string, T, it is required, and the reaction of the hinge on the rod. Now we know that the weight of the rod acts directly downwards like this, in this direction. Here is the weight. Okay. And the line of action of the string will meet the line of action of the weight in this point O. So the third force, R, its line of action must pass through the point of intersection of the two forces, W and T. So the three forces met at one point O. Here. Now we know that the three forces act at one point in case of equilibrium. Now, what is the triangle of forces here? The three forces are acts on the same cyclic order in the triangle ODA. ODA. The tangent T in the direction of OD and the W acts on DA. Of course, I draw DA parallel to EO. Note that the line of action of W is parallel to the third side of the triangle of force, of course. So we can represent the three forces in this triangle, DAO. Now we want to know the side length of each side. What is the length of AD? What is the length of AO? What is the length of OD? Now we must calculate it. Okay. Let's start from here. We know that measure of angle DAC equals 90. DAC equals 90. Because in equilibrium, AD is in a horizontal position and the AD is a vertical, right? So AD in this triangle ADC, AD equals DC square 50 square minus AC square, it's 30 square. So AD equals square root of 50 square minus 30 square, which equal 40 centimeters. Now we know that AD equals 40. How we calculate the length of DO and the length of AO? Let us start again with similarity. We know that AD is parallel to EO. AD, it's the vertical, parallel to EO. So triangle DAC, where is triangle DAC? Triangle DAC. DAC, this one, is parallel to, is similar to triangle OEC. These two triangles are similar. Now, we know that the corresponding sides are proportional. So, DA over OE equals AC over EC equals DC over OC here in this proportion. So now I'll substitute DA equals 40 and the AC equals 30 and the DC equals 50. Now what's the length of OE? We don't know, so we write it. What is the length of EC? It's equal 15. Why 15? Because E is the midpoint here. E is the midpoint of AB, right? Right. What is the length of AB from the given? It is 90 centimeters. So EB equals 45 and the AE also equals 45. The length of AC is 30. So CE equals 45 minus 30, which equal 15. That's why I substitute EC equals 15 equals 50 over OC. And now we complete. What is the length of EO? EO equals 40 multiply 15 over 30, which equal 20. Okay? You can use your calculator. What is the length of OC? OC equals 50 multiply 15 over 30, which equal 25. Now we know that EO equals 20 here. OC equals 25. Okay. Now what is the length of DO? It's 50 plus 25, which equal 75. In triangle AEO, we know the length of AE equals 45 and the length of EO equals 20. So what is the length of AO? AO equals the square root of AE power 2 plus EO power 2 as the measure of angle CEO equals 90 degrees. Always the weight W acts directly downwards, vertical. So substituting AE equals 45, EO equals 20, so AO equals 5 root 97. 5 root 97. Now we know the length of every side of triangle AOD, the triangle of forces. So we can use the rule. So triangle DAO is the triangle of forces. Triangle DAO is the triangle of forces. Now using the triangle of forces rule, we have W over dA. Here is W over the length of dA equals R over the length of AO equals T over the length of OD. And we'll substitute everything. W over 40 equals R over 5 root 79 equals T over 75. Of course, the answer will be in terms of W because it is not given. So R equals 5 root 79 multiply W over 40. And its simplest form here will be root 79 over 8. Divide 5 equals 1, divide 5 equals 8. And the unit will be kilogram weight. And now T equals 75 multiplied W over 40. Here we have T also using cross multiplication equals 75 multiplied W over 40. And we can simplify it dividing up and down by 5. So the tangent equals 15 over 8.